Morning students. Today we are going to discuss in detail about bus types. There are two types of bus. One is called a synchronous and asynchronous. And bus is used for communicating the data transfer that takes place between various devices with the help of a bus. A bus is a bunch of wires. So it is a visual photograph that is showing what is a bus. Bus is only a collection of wires. Based on the need, the buses are classified as a process memory bus, IO bus, backplane bus. Process memory bus is short and speed. Between the processor and the memory, the data is transferred for doing calculations, arithmetic or logical operations. It will be used here. So it connects directly to the processor. It is optimized for catch block transfers. IO bus is for transfer between the input-output devices to the keyboard, or from the keyboard or to the IO devices. Monitor, we will use the IO bus. Then there is another type called as a back plane bus. Back plane bus is a standard or proprietary, so it is available within the computer. What is the disadvantage of a bus is either whether it is although it is used for using the transfer of data, there are some disadvantages. If you increase the number of devices, the components in the computer, then there will be a bottleneck that the two devices ask for the same bus. So at the time there will be a communication bottleneck that exists. So the bandwidth of the bus can limit the maximum of IO input. The maximum bus speed is largely limited by the length of the bus and the number of devices on the bus. So this is one of the important disadvantage of a bus. Now, in the first type is called a synchronous bus. In the synchronous bus, the devices are communicated by a common line, clock line. So they are equally spaced intervals that is available. Multiple cycle transfer is used for by the multiple cycle transfer is used by the asynchronous bus, whereas synchronous bus is not using that. So because the transfer has to be completed within one clock cycle, the clock period must be chosen to accommodate the longest delay. So the process has no way of determining whether the address device has actually responded. So the solution to the synchronous bus is the control signals are introduced that represents a response from a device. These signals inform the bus that the slave has recognized its address and that is ready to participate in the data transfer operation. The second type is called as asynchronous bus. An alternate schema using the handshake between the master and the slave is a asynchronous bus, whereas synchronous bus does the data transfer only one at a time with a common clock pulse. But here the common clock pulse is replaced by the two timing signals. One is master ready and another one is called as a slave ready. So the handshake protocol starts by whether you are ready to transfer. All the devices are ready to transfer the data by the master ready line. This causes all the device on the bus to decode the address and ready to transfer. The slave is also activated by the signal called a slave ready line. The master waits for the slave ready to become asserted before it removes the signals from the bus. So this is a handshake protocol, the diagrammatic representation. Master ready signal is activated, then slave ready is activated. Then only the data transfer takes place between the devices. This is applied in the asynchronous transfer only. So there, even though in the asynchronous, there is a skew that occurs. The problem is skew. Skew means simultaneously the transmitted data from one device to another device are different at different times. So there is a delay in the data. So it has to be completed by it has to be solved by the full handshake. So a change of state in one signal is followed by the change in the other signal. So this save ready signal is done within a single piece. So single bus cycle that is available. What is the advantage of asynchronous bus is the handshake process eliminates the need for the synchronization of the sender and the receiver clock, thus simplifying the timing design. So the timing diagram and the timing delay is reduced by the asynchronous bus with the help of a clock cycle. When the delay, the propagation setup time changes, the time of the data transfer adjusts and transfer automatically based on the new condition. But for synchronous bus, the clock cycle will be designed to ensure proper synchronization. The rate of transfer on the asynchronous bus is controlled by the handshake, which is limited by the fact that each transfer involves two round trip delays, but in asynchronous buses. So faster the rate is achieved in the end-to-end propagation in case of asynchronous bus. So this is a data transfer, the character transfer of 8-bit data between the starting and the end in case of asynchronous transfer. So there are two types of transactions. One is called as asynchronous and synchronous bus. Synchronous bus has a common clock cycle and it is very slow. Only one data can be transferred at a time. Whereas in case of asynchronous, we follow a handshake signal with the support of the handshake master and the slave ready symbol. We are transferring the data. The asynchronous mode is usually for avoiding the delay, or the propagation delay is avoided in case of a asynchronous serial data transfer. Thank you, students.